Okay, now that goes over there. I just want to show you Canvas for a few moments. Okay, this is my version of Canvas. I guess I could put it on student view, it look more like yours. Right, this is your version of Canvas. Right. This one here where we put, the link that you use until May for coming to this class. If you go down a little bit further, do you see it says this fella? There's our first 2 lectures. So if you're wondering where the darn are they hiding, this is where they're hiding. So for instance, if I was doing that shortcut with a calculator, remember that Y1 thing and all the buttons I had to press to make it happen, you might not have been able to keep track of it. It happened pretty quickly. Well, why don't you go and have a look at the video and pause it and, get practice doing it that way. So if you're interested in, oops, I shouldn't have done that. There we go. Here it is. Okay, that's me done that little thing. Now, I will get started on limits. Well, let's see what we got here. Here are some notes. That's not good. I may have to push this up a little bit. I didn't realize I was there. Can you see everything from the top to the bottom at that position? Okay, so I'll just talk through this. You can decide whether you just want to copy what you see here. Maybe you'll go back and look at the video, right, from class, right, from lesson 3, and you can, write it down in your own, or you might just want to listen, and if it makes sense to you, it'll be in your brain anyway, right? So whatever suits you. Let's look at an unusual function. A piecewise function is a really good example of how we can use what are called left and right limits. So here is a piecewise function that has a problem at 5. So forget about tangent lines right now. Just think about finding the value of a function as x tends to 5 here. Well, the left limit, which we use this notation here, the limit as x tends to 5 minus. There. Put some more light. That might help. There we go. Maybe that's too much light. Darn it in space. There. That's a good compromise, isn't it? I think it's reasonably clear now. Okay. So back to this fella. What's called a left limit is written like this. And you read it out loud as the limit as x tends to 5 minus of f of x. So what does that mean? Well, it represents what would be the value of this function as you get closer to 5, coming in from the left-hand side. You see how this is on the left-hand side? Made it green just to separate the colors. And the value of the function as you get really close to 5 is 3. Now, technically, there's a little open circle. If you remember in 141, doesn't that mean the value of the function at 5 isn't 3? Isn't the value of the function actually this number up here? Couldn't the dot be in the middle, in which case the value of the function might be 7? So the limit of a function isn't where that solid dot is. It's basically what's this function trying to be. In this case, the limit as you're coming in from the left-hand side is 3. And that's what we call a left limit. It's the value of a function. As you get closer to a specific number, in this case 5, but coming in from the 4.9999 side. Would you agree as you get closer and closer to that, isn't this function going to get as close as you could ever want it to be to 3? Now, what did the right limit look like? Pretty much the same idea. Can you imagine this function now, but you're coming in closer and closer to 5, but you're coming in from the right-hand side. So that's why it's called the right limit. And in this case, it's 6. What is the value of f of 5? in this particular picture, what is the value of f of 5?
6.
Yeah, isn't it where the solid dot is? This is a 141 thing. Right. The solid dot represents where the value of that function is at one specific number at 5. Now, in this particular case, do you notice that it belongs to the branch that's on the right-hand side? Couldn't I have made that solid dot an open circle, just like this fella? If I'd made an open circle, wouldn't the limit, the right limit, still be 6? It doesn't care if there's a dot there. In fact, couldn't I make that an open dot and stick the dot right in the middle? So the value of the function at 5 was 4 and wouldn't have still no effect on limits. The limits don't care what the value of the function is. They don't care where the solid dot is, or even if it did have a solid dot, right? So don't let, oh, that's got a solid dot and that's not affect your answers. The left limit is still 3, the right limit is still 6. I don't care as far as the limits are concerned. Where the function's value happens to be. It might be there, it might not. And then we have a third kind of limit. It's called the overall limit. And its notation is you just say the limit as x tends to 5 of f of x. This one here, the overall limit, is actually the most common limit that we want to calculate. Because this thing here that says f of x, this will get replaced later by the rise over run, right? You know, the y3 over y1 kind of thing. And so if we can have an overall limit, we'll be able to estimate what the slope of the tangent line is and actually get the exact value of it. So how do you calculate the value of the overall limit? Well, it's a bit messy, but it's pretty intuitive, I think. Does the left limit and the right limit, are they both the same number? So if the left limit says you're trying to be 10 and the right limit says, yep, you're trying to be 10, the overall limit is 10. That makes sense. If the left limit says you're this number and the right limit says you're that number, you're 10. Okay, what could go wrong? Well, the left limit and the right limit, like in this example, couldn't they be pointing at different values? If that happens, the overall limit does not exist. If the left limit and or the right limit themselves don't exist. Now you might say, how on earth can a left limit not exist? Well, can you imagine a function that at x equals 5 looks something like this? You ever seen one of those sine of 1 over x's that has a real problem at 0? Couldn't I do the sine of 1 over x minus 5? Wouldn't it zoom up and down and you wouldn't be able to tell the limit? That would be an example of in this case, a right limit not existing. And the left limit might be up here. So it could have a left limit, but no discernible right limit. So an overall limit exists if the left and right exist and agree with each other. And if they don't agree with each other, or one or both of these don't exist, then the overall limit doesn't exist. And that's the idea behind a left and a right and an overall limit. Any questions so far? Because really, I think doing these questions will make the idea a lot clearer. So let's see if I can find the darn question now. Is that it? No. Go away. Oh, here we are. Are you looking at question 1 in the WebAssign? Or will I have to go out and in? Can you see question 1?
No, we're still looking at the book.
Okay. Right, let's close out. I don't know why it doesn't update. It would really make my life easier if I didn't need to keep asking people, but there we go. Here is a weird looking function. It's called h of x. And here are various left, right, and overall limits. There is no real working attached to these questions. And didn't we need to do that? Did you notice, everybody? I did not swear there. Did you see that? Did you see the self-control I had? I meant to close the other box, so you're going to have to wait a few moments.
Beautifully controlled. I'm proud. My aunt has taken you in the past as a professor, and she said that, and my grandparents are pretty conservative, but she said that you had sometimes a pretty foul mouth.
Oh, oh. When I meet them, we are going to have some words. That's all I can say.
She said she loves you though. She thinks you are one of her all-time favorite professors.
I'll take it back. Maybe I should phrase, I try. Oh, darn it in space. Okay, guys, you're going to have to wait a few seconds because I screwed up there, as you can see. I'm going to have to log back in, which is a real pain in the butt. You know, this is the kind of thing that doesn't happen when you are physically in a room. I can't accidentally hit a piece of the whiteboard and the whole whiteboard disappears on me, right? That just doesn't happen. But in the electronic age of hitting buttons and closing windows, it's dead easy to do what I just did. I'm almost there, guys. Right.
On the news yesterday, they said that cursing is a sign of intelligence.
They did?
Yeah, and I was like, yeah, good.
I don't know. I think that's probably a scientist who swears a lot, who probably wanted to have that as cover. Okay, I got the guy finally. Thank you for your patience, everyone. Here we go. Okay, we should be looking now at question 1, and you should be seeing a graph. The guy that was trying to kill off, I don't even think you can see it, but there's a little window here to the right-hand side, which I'm just going to pick up and drop on my other screen. That's it. So in each of these questions below, we are going to look at this function, and we are going to find the left limit, the right limit, or the overall limit. Now, I'm going to show you something that is quite distracting. I don't know if you can see it, but I can see it. When I move my mouse pointer over this graph, there's a whole load of writing suddenly appear, which is really a pain in the posterior because I want my mouse to be pointing on the graph. So we are going to have to just work with this. So I'm going to kind of talk about where it is, because if I try and point, it'll disappear on us, right? So if you're wondering why I'm not just, why can't you make the mouse pointer go there? So let's look at this function. It's got lots of interesting places. If I asked you, oh, I could probably at least do this. If I asked you to find the left limit as x tends to 0, so that would be the limit of h of x as x tends to 0 minus. Right? If I asked you to find the left limit as x tends to 0, do you see the answer would be 1? If I asked you for the right limit as x tends to 0, would you agree the answer is -1? Right?
I don't know. I was kind of thinking that there was a limit at 4 and 1 from the left.
Okay, we are imagine my mouse pointer is going along the x-axis, because I can't do it because that happens.
You might be able to use the annotation though at the top on the share screen. There's an annotate button and you can write with it on the screen. It says view options at the very top.
It does in yours. I'm trying to find it on mine. I'm not sure I can move it onto a WebAssign page. I may be able to do that, but I can't. I'm not going to. Oh, okay. Somebody's doing it.
There you go.
Got it. There you go. Okay. Now, the guy I'm talking about is at x equals 0, right? Right here. Now, if you do the left limit, you're coming in from the left-hand side. Do you see that the value of the function is that dot at 1? If I ask you for the right limit as x tends to 0, do you see that the dot, it's a little open circle, but it's at -1. So that's those two. The overall limit, the limit as x tends to 0, does not exist. And it doesn't exist because the left and right are different numbers. Okay, let's move over to x equals 2. Wouldn't the left limit and the right limit both be 2? The left limit as x tends to 2 is the value of the function as x gets closer to 2, and that is 2. I'm about to point with it with my mouse. There. See the guy? I am not seeing happy faces here. I don't know if it's just me being frustrated or you lot are okay with this. Are you okay with this?
Wouldn't that just be the right limit, not the left? If
For
it's coming-
which one? For
The one
x
you were just
tend-
pointing at x equals 2. And then
as x tends to 2, there's a left and a right limit, and both of them are 2.
Ah,
I
geez.
know what I can do.
See, I was looking at this guy and thinking that was the left one, and I was looking at this guy over here and thinking that was the right one.
No, I
same.
know what
That's
you're doing,
wrong.
but that's not
It's all
what
the
it
same
is.
function.
Okay,
Alright.
they're all one same function.
Okay.
I'm going to do a different version of that question then, and then I think next time I'm going to figure out a better way of not having this mouse just make my life a misery. Right.
If you want to mouse over it, you can press Windows Shift S, and mouse over it and create a little box over it. Then it'll clip it, and you can put it into Paint, and then you'll just have.
Oh,
it as a
you want me to
picture.
copy it and do it that way? Yeah, I
you
could
could
certainly-
just have it as a picture.
Yeah. Okay. Well, here is a sort of a workaround to show you what is going on. This thing at x equals 0, that's the little snapshot of the place I was talking about. And so when I say the limit, that's a left limit, and that is 1. And the limit as x tends to 0 plus, that is -1. And since they are not the same, the overall limit as x tends to 0 does not exist. So that's what I was trying to say in a very frustrated kind of way. So, are we comfortable now about what you do? You only look at the little bit roundabout, in this case 0. There is only one function. I think actually it's called h, but f of x, whatever letter of the one. Now, if we move on and we look at a different part of the curve, at x equals 2, the curve looks something like this. Right? It's all part of the same function. It's all part of h of x. Now, if I ask for the left limit of this function, and I ask for the right limit of this function, let's see what happens. As x gets, oops, what is that number? That number there happens to be 2. As you come in from this direction, isn't the value of the function 2? And if you come in from the right-hand side, isn't this also 2? So in this second situation, the overall limit as x tends to 2 exists, and it is whatever these guys are. So is that a little bit clearer what I'm trying to get across visually? That there's a left, there's a right, and there's an overall. And in some situations, the left and right might exist, but the overall won't. In other situations, the left and right exists, and so will the overall. And in this world, won't everybody be the same? We even have a name for this. Functions that do this, as long as that little hole is filled in, would be considered continuous functions. And they are good because we like that. We don't like this situation because basically it means it's finding derivatives are going to be very difficult, if not impossible. But we do like this situation. Now I'm going to return back to this picture and we're just going to do it verbally. Hopefully that's enough just to do some more practice. Okay. What is the overall limit as x tends to -3 in this picture? What number is the overall limit as
4.
x tends to, agreed.
It's 4.
Can you see the top of the hill? We're cool. Now, do you see that? I don't know quite what to call it, but do you see that dense ziggy-zaggy stuff that's going on round about 4? I think it's trying to be at 4, but it could be at 5. Do you see that ziggy thing going up and down? And it's almost solid now. That would be an example of a limit not existing, right? Because the function goes up to 4 and it goes down to 2, and you won't be able to tell as you move along what it is, because no matter how close you get to the number, it's still going to go up and down forever. So there would be a does not exist. And here are some examples of that. Right, here's a much simpler picture. Might even make it bigger. So I'm just going to talk this one. Right. What's the overall limit as x tends to 4?
4.
Right. What is the left limit as x tends to 2?
3.
And the right limit as x tends to 2?
1.
And so the overall limit as x tends to 2, dne, does not exist. Now, these are not limit questions I'm about to ask you. This question is, what is the value of f of 2?
3.
And is it not because that's the dot, the solid dot is at 3, right? The height is at 3. That's what the value is. And this is a kind of trick question. What is the value of the function f of 4?
Doesn't exist.
Because there's a little hole there. So can you see when you're doing your homework, your answer is going to be 4, 3, dne. You know, it's either going to be a number or it's going to be a dne. And that's what these are about. Okay, I think things are moving much smoother. Right, let's look at this one. What is the value of f of 3?
3.
Does the overall limit as x tends to 3 exist?
Does not.
Right. You see how quick your homework's going to be now? Right? Okay. Now, what this one does, it adds another layer to what limits are. If you remember 141, you've probably seen graphs like this, aren't these vertical asymptotes? Right, that's essentially what's going on here. Now, normally you would say, I don't know what you would say, probably something like undefined, you know, when a vertical asymptote arms, right? But we are going to allow a different answer, a little bit more precise answer. When vertical asymptotes are involved and you're looking at limits, your answers are allowed to be plus infinity, minus infinity, or does not exist. So an overall limit or a left or a right limit can be plus infinity, negative infinity, or does not exist, right? So instead of you just saying undefined, 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 right, every situation, we're now going to be much more precise about it. So looking at this picture, if you look at x equals -3, do you see the vertical asymptote there, right? If I asked you for the overall limit as x tends to -3, the answer would be plus infinity, right? You just write infinity down, but everybody knows that's plus. And if I asked you for the overall limit as x tends to -1, would you agree that it would be negative infinity in this picture? What would you write for the overall limit as x tends to 2?
Does not exist.
Because aren't the left and right limits not the same? Because won't the left limit be negative infinity because it's zooming down the way, and the right limit would be plus infinity, it's zooming up the way. So when you are dealing with limits, and the limits are where vertical asymptotes are happening, instead of your answer being 2, 3, or does not exist, your answers will now be plus infinity, minus infinity, or does not exist. So you see how we're going to adapt that. Now, if you click on a box to put your answer, a little, I know what you want to call it, a little palette appears, and there's an infinity symbol that you can hit there, and that's how you get infinity into the box. So if you're wondering, how am I going to type infinity? You know, I don't have infinity on my keyboard, you know, that kind of shit. When you click on the box, there's a little table that appears, and you can, the infinity symbol is there. I think the pi symbol is there, and some others are there as well.
Do you
I
need
think
to
this is,
say plus infinity and negative sign infinity? Do you have to do the plus sign infinity?
you don't need the plus for plus
Mm.
infinity, because we assume that it is positive, but you need to put it in for negative infinity. So you'll do a normal negative symbol and then infinity after that. I was saying, I think this is going smooth. Right? Are we getting comfortable with, if I gave you a graph, left limit, right limit, overall limit, right? It's a number or it's infinity, whatever it happens to be, depends on the picture. Right, here's a weird looking piecewise function. It's really just weird. It's not different. What's the left limit as t tends to 12?
$150.
Yeah, I'm beginning to change my mind here. Okay. There's 150. I've got a sneaking suspicion that isn't it climbing upwards every time? So it might be 160. You have 5 shots. I'm sure you'll find the right number eventually. Oh, they're doing 4. Okay. Oh, that's actually not a very nice choice, because that looks to me, I should be able to do that. No, can't see it. Oh, here's my infinity guys. I like them. They're much nicer. Question.
If you hold your mouse over the graph, it tells you the points that each part.
So yeah. So actually that writing has got some advantages, at least for that question.
So you don't actually need to guess.
Which is so much better, because I'm hopeless at guessing. Okay. This guy is a classic, vertical asymptotes gone wild, right? What is the overall limit as x tends to 6?
Undefined.
It does not exist. DNA is what you'll type, but I agree with it. What's the left limit as x tends to -3?
Infinity.
Okay.
Positive.
Yeah, positive, thank you. What's the right limit as x tends to -7?
Negative infinity.
Agreed. Here's a trick question for you. What's the left limit as x tends to -4?
One.
Wasn't much of a trick then, you got it. Yeah. And that's the kind of thing they're asking here. Right. Yeah, we've got time. So what we're going to do now is zoom back to the whiteboard and have a little look at kind of an early taster of what's going to happen in the next section. We're going to find the limit as h tends to 0 of this expression. Now, I'm going to tackle it the way maybe the first person who had to deal with this would probably have done it. Okay, you want to find the value of this function. You want an overall limit. So you're basically trying to find out, what does this equal when x gets really close to 0? Great, that's essentially what you're saying. So I'll plug in 0 and see what I get. Well, I get 0 take away 8 squared, take away 64 over 0. Okay, that's -8. Square -8, you get 64. Take away 64 over 0. And then we get 0 over 0. We even have a name for this when it happens. We call it indeterminate form. It's really just a phrase for, we don't know what that's equal to. It might be 0, it might be 42, it might not exist at all, right? It might be a DNE. I don't know. Now, I could call that f of x equals x minus 8 brackets squared, take away 64 all over 8, right? I could do that, and I could see the graph of it, and then couldn't I do what the limit looks like as h tends to 0, right? I could visually do that, right? Maybe if I've got time, I'll actually do that guy on Desmos and show you what he looks like. But here is another way of looking at that problem. Foil that guy out, you get h squared, take away 64, 8. No, yeah, sorry, I can't count. You get h squared, take away 16h plus 64, take away 64 all over h. You get the limit as h tends to 0. Now, if you cancel this guy with that guy, would you agree that they cancel out? You now have h squared take away 16h over h. And you might think, well, that didn't help much, because if I plug 0 into that, don't I still get 0 over 0 indeterminate form, and we're no better off than we were? But let's keep going. Does anybody notice anything that I could do with the numerator here?
Yeah, factoring out the h.
And can't I now, at least algebraically, I should be able to cancel those, right? They're factors, which means that I'm now going to be looking at the limit as h tends to 0 of h take away 16, which means that we actually know what it's equal to. That guy is actually -16. You can't get it by plugging 0 into the untouched form, because it generates an indeterminate form, right? You don't know what that is. But can you see, with a little bit of algebra and combining and factoring and cancelling and, you know, whatever it is that you have to do, can you imagine that sometimes this nice situation might happen and we'll actually be able to get a numerical value for the overall limit? Now, I'm frightened based on what I did last time to do this, but I'm going to try, because I'm a glutton for punishment. I'm going to try and see if I can do Desmos and show you what we've just found out visually, algebraic. Right. Okay, it takes a few seconds to get into the right place. There we go. I'll close this off now. I'll go back in and let's see. Hopefully, are you looking at Desmos? And I'm going to just call the function y equals, and it's going to be a fraction, isn't it? So I'll need this fella. Do we have the ability to do a fraction? I think I should just be able to do it with brackets then. So it's going to be a bracket.
To make it a fraction, just
Yep.
press the /.
Okay, gotcha. So x take away 8 close brackets squared. That's basically h minus 8 squared, right? And then take away 64 and finish off the bracket divided by, just like you said, an x. Would you agree that that's equivalent to h minus 8 squared over h, right? It's the same thing. Now, I don't want that anymore. And hopefully when I click out, where is that? As I say, yeah, 64, good, h, and it's at 0. And if I move it up a little bit and I move in a little bit, would you agree that that guy there, if you look at the scale, isn't that exactly what I said it was? Isn't that negative 16? Now, I hope Desmos is about to do what I want it to do. I am going to zoom in here and I want to see a hole, right? A little open circle. I don't know how zooming in you need to go to make this happen. No, okay. Can you trust me that there is a hole there? And the reason why there's a hole there is that if you think of this as a function, isn't this function undefined at 0? So maybe Desmos just doesn't bother about it, but it would have been nice if they did it. Actually, if you do it on your TI-84 and you zoom in, you won't see the hole, but what you'll see is a little gap where the hole should be. So it does exist. Is it? I think that's kind of comforting to know that this technique I just used works, doesn't it? It told you the value as, in this case, h tends to 0, and that's pretty cool. So what we're now going to do, if I can get back into my white screen, right, and close all these various windows off, and go back, here we go. I can now talk about some more homework questions. I just did that one, algebraic. This one, you're going to do by graphing it. Now, if you plug this guy into Desmos, you will see that there is a problem at 0. And this guy will be a different number from this guy, and the overall limit will not exist. So what you do is you plug this into Desmos or your graphing calculator, and you just look at the picture, and as x comes to 0 coming in from the left, the graph will be one number, but coming in from the right, it will be a different. It's basically it's a piecewise function. And let's look at this fella then. The last thing that we're going to look at is how to find limits using tables of values. Here we go. I'm going to show you a cheat for that. We are interested in the limit as h tends to 0, so it's an overall limit of 2 plus h cubed, take away 8 over h, and then it has a whole load of values that you're going to use for h, tons and tons of them. And then they have a table where they do H, and they do f of H, and then they have another bit next to it, and it goes H, and it does f of H. And the first one has 0.5 in it, and the other one has negative 0.5 in it. And I'm going to put a kind of colored borderline because these two are different from these two. Now, there are two ways in which you can do these tables. And if you do them, they will take you forever and a day if you do them basically as individual calculations. So what you can do instead is you can use a nice feature on the calculator called table. So if you've never used it in the TI-84, let me show you how to calculate this expression for lots and lots of different values of H. You're going to be calculating something like 12 different values, so you don't want to do it all day. So I'll click over here, open it up, and let's show you. You're looking at a calculator, a TI-84.
Yes.
Right. So watch what I do here. The function, I'm pressing Y equals. It's a bit messy, but it's a bracket. Then I do another bracket. And instead of 2 plus H, I'll do 2 plus X, which is essentially equivalent to it. And then I'll square it. Oh no, I won't, I'll cube it. Then I'll subtract 8. And then I'll divide it by X. So that is essentially the function, right? The one you want to get tons and tons of values for, right? And then you go blue button, table setup, and go down here and just change that to ask. That's all you need to do. And lastly, you go second, not table setup, but second table. And I will put in 0.5. There's the answer. Negative 0.5. There's the answer. 0.1. There's the answer. 0.01. There's the answer. 0.0001. There's the answer. Okay, I know that looks funny, but isn't that just 0.01 in scientific notation? Now, if you were a betting person, would you agree that it looks like, if you're coming in from the positive side, right, the right-hand side, 0.00001 side, and would you agree that the answer looks like it's 12? Right? Now, let's suppose we came in from the negative side. So negative 0.1, negative, negative 0.01, and maybe negative 0.0001. Would you agree that it's also trying to get closer and closer to 12? Would that be a reasonable assumption? So wouldn't your prediction be that the overall limit for that particular question was 12? Now, you got to make sure, Robin, you've got brackets around it. If you're not getting the same numbers as me, it might be just a missing bracket. Are you getting the same numbers as me? Perfect. Oh, you put in tons more decimals as well. So that is good. Isn't that a reasonably quick way of doing a whole load of calculations, just using the table feature of your TI-84? Can you see how helpful the TI-84 is going to be right now, for this week especially? Any questions? Because I think we've reached a natural starting point.